inverse matrices and matrix algebra. It can be shown that the inverse of the inverse of A is A itself. We mentioned before that A and the inverse are actually inverses of each other. So A is the inverse of the inverse, which is what we just said. So A and the inverse of A are inverses of each other. It's such an important point, I want to stress it again. Now, Ka inverse is 1 over K A inverse. This is fairly self-explanatory, since this is the inverse of A, and K times 1 over K is equal to 1. So the 1 over K here is to deal with the scalar part, and then the inverse of A gives us the inverse for the matrix. Now, if we have the matrix product AB and we want the inverse of that, it's equal to the inverse of B multiplied by the inverse of A. Note how the matrices have swapped order. This one is easy to demonstrate. So if we take AB and multiply it by what we've said is the inverse, we know that matrix multiplication is associative. So we can change where the brackets are. And if I do B multiplied by its inverse, I get the identity. And A times the identity is just A. And then A times its inverse is the identity. And that's the definition of an inverse. We multiply them together and get the identity. Of course, we have to show it the other way around, but if we do it the other way around, it works in much the same way.